Hey everybody, thanks for checking into another math video. This one is a number tricks video also, and it's called Rationalizing a Denominator. I'm going to show you a little trick called Rationalizing a Denominator here, okay? Well, first, let's take a look at a fraction. 3 divided by the square root of 2. Okay, do you like that fraction? Do you think it's kind of cool? Do you think it's nice? Whatever? I don't know. Well, you might be surprised to know that there are mathematicians who are a little bit sad looking at that. If you left that answer on your paper, they'd be a little unhappy about that. In fact, some very picky mathematicians might be a little angry because they might think that that answer that you wrote there is wrong. All right? Wrong in a certain way, I should say. All right, well, what about a different fraction, like 3 times the square root of 2 over 2? What do you think about that fraction? You like that one better? I don't know, it looks a little messier to me, but I'll tell you, those picky mathematicians, they'd be much happier with that one. Now, why would they like the one on the right, but they don't like the one on the left? What's wrong with the one on the left? Well, this is a kind of a curious question, especially since if you put both of those fractions into a calculator, you get exactly the same thing. It turns out that 3 divided by the square root of 2 is exactly the same number as 3 times the square root of 2 over 2. Why is that? All right. Well, that's what this video is going to show you. I'm going to show you a simple process here called rationalizing a denominator. Now, we'll talk about rationalizing in a second, but I'm pretty sure you, just to get it out of the way, pretty sure you already know what a denominator is, right? It's the number on the bottom of the fraction. All right, so rationalizing, what the heck does that mean? Well, the square root of 2, for example, is called an irrational number. Any number that's underneath a square root sign, for example, and does not simplify down to a nice perfect square root, is called an irrational number. And what this video will do is show you a simple process to change an irrational denominator into a rational denominator. Hence the phrase, rationalizing a denominator. We're going to take irrational denominators and make them rational denominators. All right? Okay, well, before we get started, there's a couple of important reminders that I wanted to bring up here. These are things that you already know, but we're going to be using these little math facts here in this process. Number one, when you multiply fractions, you remember how you do that? You multiply fractions, some people call it, you multiply straight across. You multiply numerator times numerator, denominator times denominator. For example, 5 over 3 times 7 over 8 is 35 over 24. Or 6 over x times 5 over y is 30 over xy. Or here's another one. Square root of 5 over 2 times the square root of 5 over 6 equals 5 over 12. Now, I'm not sure if you noticed this, but look what happened there in that first one. That actually brings up my second point that I want to remind you of, and that is when you multiply a square root times itself, in effect, you simply remove the radical of the square root. Like the square root of 2 times the square root of 2 just equals 2. Or the square root of 3x times the square root of 3x just equals 3x. All right? So that's an important little fact that we're going to use in this process called rationalizing a denominator. And finally, the last thing would be that when you multiply a number by 1, it does not change the value of that number. It might change the way it looks a little bit depending on your version of 1, whether it's a fancy version of 1. You might change the way the number looks, but it does not change the value of that number. Okay, so let's get back to that. I guess that was 3 important reminders, wasn't it? All right, so let's get back to this fraction here, 3 divided by the square root of 2. All right, so I want to change that denominator into a rational denominator, and I know that if I multiply that fraction by something that equals 1, I won't change the value of it, which is good. I don't want to change the value. I just want to change the way the denominator looks. Well, keep in mind that any number over itself equals 1. So I can pick any number in the universe and make a fraction of that number over itself, and that fraction equals 1. So what number would be a good one to pick here? Well, it turns out that if I pick that radical on the bottom, that square root of 2, and make a fraction out of it, or square root of 2 over the square root of 2, that fraction equals 1. And what it does, it doesn't change the value because I'm multiplying by 1, but it also does change the way that the fraction looks. 3 times the square root of 2 is just 3 root 2. Notice that the 3 does not multiply the 2. They stay separate. Numbers outside only multiply numbers outside, and only numbers inside the radicals can multiply other numbers inside radicals. That sounds a little confusing, but you got to keep them straight there. But the square root of 2 times the square root of 2 just equals 2. Okay, so there you go. That's the fraction that we were looking at there. That's why those two fractions are equals. 3 over the square root of 2 is the same thing because I'm just multiplying it by a version of 1. All right, so that makes the picky mathematicians very happy. Okay, let's do a few more examples here. And you can feel free to pause the video at any time and give one of these a try if you want to work it out for a little bit yourself and see what you get. Okay, so that first one there, 5 over the square root of 10. I'm going to multiply the top and the bottom by the square root of 10. All right, and that gives me just 5 times root 10 on top, and it gives me just plain old 10 on the bottom. All right, well, that's pretty good, but I can go even further because I have 5 outside of the radical on top, and I have a 10, which is a rational number, also on the bottom. I can simplify those by a factor of 2, and there I have 10, square root of 10 over 2. That's pretty nice. That's much simpler. Okay, let's try the next one. 8 root 3 over root 6. If I multiply the top and the bottom by that radical from the bottom of the fraction there, square root of 6 over itself. All right, watch what happens here. I'm going to get 8 times the square root of 18 over 6. Notice, once again, that square root of 3 times the square root of 6 gave me the square root of 18. The 8 on the outside of the radical did not multiply anything there yet. Okay. However, now I have a rational number on the bottom of the fractions, plain old 6. And 8 over 6 does reduce. They're both even numbers. So I can reduce that fraction down to 4 times the square root of 18 over 3. Well, if you've seen the other number trick video that I showed you about simplifying radicals, you might recall that the square root of 18 actually can be simplified down to 3 root 2. So I'm going to replace 3 root 2 for that square root of 18. And now look what happens. I got a common factor of 3 on the top and the bottom of that fraction. I can cancel them out, and I'm just left with 4 times the square root of 2. That's much better. It's not even a fraction now. Let's try the next one. 2 root 5 over 5 root 2. Well, I put that in there just to kind of be annoying. You'll see it works out pretty nicely. But you're going to multiply the top and the bottom by the square root of 2. All right, that's the radical from the bottom of the fraction. Just use that one. And just the radical part. You don't have to multiply by the 5 on the top and the bottom. Just leave that there because that's already rational. So that gives us then 2 root 10 on the top. And when I multiply the 5 times the square root of 2 times the square root of 2, remember those two radical 2's will just give me plain old 2. So that gives me 5 times 2 on the bottom. And once again, there's a common factor that I can cancel out of my fraction to reduce the fraction down to root 10 over 5. Much nicer there, okay? Picky mathematicians like all of those. Let's do a few more to wrap this thing up. Let's say we got 6 divided by the square root of 10. All right, well, I'm going to multiply the top and the bottom by that same square root of 10. All right, that gives me 6 root 10 on top, plain old 10 on the bottom. I reduce it by a common factor. You can see what's going to happen here, right? I'm going to get 3 root 10 over 5, and I'm done. All right, is that really better than 6 over the square root of 10? They do equal the same thing. And so it's a curious question. Why do mathematicians like that one there, but they don't like that one on the left where we started? Well, it's an interesting question. I'd love to talk with you about it sometime in person, but it's a little bit outside the scope of this video. So let's do another example here just to get this process really wired. Let's say we had the square root of 30 over the square root of 5. All right, well, let's see. I'm going to multiply the top and the bottom by the square root of 5, I guess. And that gives me on top then the square root of 150. But on the bottom, I get a nice rational 5. Now, the square root of 150, once again, that's from that other video that I made, does simplify down to, because 150 is 25 times 6. 25 is a perfect square, so the square root of 25 is 5, and so I get 5 times the square root of 6. That square root of 150 is the same thing as 5 times the square root of 6. And now, once again, there's a common factor that I can cancel out of my fraction. Square root of 6 is all I got left. That's pretty nice. All right. Let's try one last one before we wrap it up here. 7 times the square root of 2 over the square root of 14. Notice, please, that 7 on the top will not cancel the square root of 14 on the bottom. You may be thinking 7 over 14, that reduces down. But no. That's really not 14 on the bottom. It's the square root of 14, which is a totally different number. All right. So you cannot cancel that 7, rational 7, with that irrational square root of 14. They cannot simplify. However, I can multiply the top and the bottom by the square root of 14. All right, so that gives me then 7 times the square root of 28 over 14. Now I can cancel out that 7 with the 14 because they're both rational numbers. Now that's cool. So that gives me then square root of 28 over 2. I hope you see how we got the square root of 28, right? That's square root of 2 times the square root of 14. But that square root of 28 actually does simplify down because it's got a factor that is a perfect square. 4 times 7 is 28. So the square root of 4 is 2. And so that square root of 28 simplifies down even further down to 2 root 7. And it's all divided by 2. The 2's cancel, leaving me with plain old square root of 7 all by itself. Much nicer, all right? So all that kind of stuff is just there to make these picky mathematicians happy. I hope it's important to you to keep the mathematicians in your life happy. It's all good work, and I'm glad you watched this video to the very end. Thanks very much for watching, and I hope you stay well, you stay strong, you stay smart, you stay cool, and do some good math out there, okay? Thanks. I hope to see you soon. Bye-bye.